All right, so you got these notes down on coterminal angles. I want to give you a few more details on these before we get rocking and rolling here. First thing that I want you to note here is that since coterminals finish at the same location on a circle, that means that the coordinates on the circle would be the same. Because if you go around and end up at the same place, the coordinates are the same. If the coordinates are the same, that means the sine, cosine, tangent, all of those values are exactly the same for any angles that are coterminal. All right. The other thing I want to note here, in our example, notice 300 and negative 60 are considered coterminal. How far apart are those two angles? 360. All coterminal angles are a multiple of 360 degrees apart. Now it can be 360 to go around once. It could be 720 to go around twice. It could be 3 times that, 4 times that, as we're going to be seeing. So we're going to look at some examples here with these 4. We're going to go through the first one together here. So for 60 degrees, we're looking to see what's coterminal with a 60-degree angle. In other words, what would drop us off at the same point? Well, one way we could get there is if I start at 60 and go all the way around the circle one full time. So notice, that means I've gone around an additional 360 degrees. What is 60 plus 360 degrees? That would be 420 degrees. All right. But of course, I can't, you can go around more times than just that. What if I added another 360 degrees to that? What? So I went around once, I got to 420. If I go around twice, I do 420 plus another 360. That would end up giving us 780 degrees. So all of these are coterminal. When I talk about all of those, they all mean this exact same angle on our circle. But of course, that was all by adding 360 a bunch of times. You can also get the same results by subtracting 360 a bunch of times. So like, what if I start at 60 degrees and I go backwards 360? Well, that's 60 minus 360, which is negative 300. And so negative 300 degrees would also be considered coterminal with 60. All of those angles would drop us off at the same point on our circle, and therefore they all have the same sine value, the same cosine value, the same tangent value. Now, in this particular question, though, you don't have to find all of these. And in fact, there's an infinite number, because we could keep adding and subtracting 360s all along. You only would need to give one of them, and it's whichever one you feel like giving as an answer. So with that in mind, now go ahead and find one coterminal, just one, for each of those 3 angles, please, by whichever method you like. All right, so for number 2 then, I think most of you, since we started with a negative, probably added 360. You didn't have to, but that's probably the most common way. So if we do negative 150 plus 360, that ends up giving us 210 degrees. And so that angle is coterminal. Is that the only answer you could have come up with for 2? No. You could have kept adding 360, or you even could have done negative 150 minus 360. That'd be fine. 225. You could add 360, but let's say you decided you wanted to subtract 360 in this case. That would have given you negative 135 degrees, just to give you one more way of seeing it. 450 degrees. Again, add 360, subtract 360. Either way, it's going to be fine. Let's say you decide to subtract 360 on this one. If you did that, that would give you an answer of 90 degrees. And so you start getting a decent idea about where some of these angles would be because of their coterminal. Like 450 degrees can be hard to envision unless we see that it's the same as 90, and then it's easy. All right, so that's the sort of thing we want to use with this. And the fact that they all have the same sine, cosine, and tangent values is going to prove important as we go forward today, because today we're going to be looking at graphing some of our trigonometric functions. So you just received a graphing grid that looks like this. This is going to be the very first graph we do. This is going to be our big parent function graph. So make sure that as we go through it that you're plotting all the points that we do together accurately. It's going to be something you're going to be able to look back on as a reference going forward. And so you definitely are going to want to make sure that it's correct as we go. Now, a couple little things, a couple little details here. We're actually going to be graphing for our parent function cosine of theta. I'm going to go ahead and call it theta instead of x, not because it changes anything, but just because I don't want us getting mixed up about cosine being x and sine being y. We're now talking a different language here, because when we talk about cosine being x and sine being y, those are the coordinates of the point on the circle. That's if I plot sine versus cosine. What we're doing today is we are plotting cosine versus theta. So we're actually looking to see how does my cosine value change as the angle changes. So it's completely independent of the sine value that gave us the circle. All right. Now, in those terms, if it helps you to remember, you might even label your axes here. My horizontal axis is theta, and my vertical axis is going to be cosine of theta. So keep that in mind as we go forward. Now, in order to be able to make this graph, we are basically going to just plot points. And we already have a ton of points that we can plot, because of course we know this table very well now. But out of this table, remember, we don't need the whole thing. Today we're just focusing on the degrees versus cosine. So I can go ahead and ignore all of those sine values. So I'm ignoring sine. All right. Now, as I go to start plotting these, I'm going to have to be able to plot this point, root 3 over 2. Do you know what root 3 over 2 is as a decimal? Off the top of your head? Probably not. Could you calculate it? Yes. In fact, there's really only two values we have to calculate out of this so that we'll be able to plot them and actually locate them on the grid. Root 3 over 2 and root 2 over 2. If you do those two calculations, might also be worth noting there as we make our graph, root 2 over 2 is about 0.71. Root 3 over 2 is about 0.87. All right, so we're going to start graphing. Now, as we go and make our graph, remember, theta is my angle in degrees. That's my horizontal axis. Cosine, that's my vertical axis. So that's playing the role of y here. Okay? So, for my first point, I'm going to be plotting this. 0 degrees gives me cosine value of 1. In other words, that is the coordinate pair 0, 1. So we're going to plot the point 0, 1 here on our grid. So I go over 0 and I go up 1, plot the dot. I next go to my next angle, and I'm just going to be going through this table one angle at a time, plotting every single point that it gives me. So the next one's going to be 30 and then root 3 over 2. Now notice root 3 over 2, that's about 0.87. So I need to go over 30 and up 0.87. Well, let's take a closer look here. So if I'm going to go over 30, that means I need to know where 30 degrees is in here. Well, notice between 0 here and 90 here, it's cut up into 6 pieces with the way these hash marks are set up. So I can know what each piece is by doing 90 divided by 6. 90 divided by 6 is 15. So every single one of these hash marks here represents 15 degrees. So, remember that I'm trying to plot the point 30 and root 3 over 2. So 30 represents 2 hash marks, and I have to go up 0.87. Well, you can see we're going up by 0.1 on our y-axis, so 0.87 It's going to be just below 0.9 up there. Notice I went over 2 hash marks to get there again. Make sure you've done the same on your paper. Having plotted that point, I'm going to go to my next angle, 45 degrees, which is root 2 over 2. And again, we calculated that. We found out that is 0.71. So we're going to have to go over 45 and up 0.71. Remember, each hash mark as I go over is 15 degrees. So if I just did 30 degrees here, 45 degrees must be here. Another way to notice, 45 is exactly halfway between 0 and 90, right? Easier to locate in some ways than the 30 is. And so I go over to 45, and I'm going to go up 0.71. So that's just above 0.7. All right, next up. Remember, I'm just going through my table as I see it. So the next thing there is 60. So 60, that's another 15 degrees past the 45 I just did. So this is going to be the next hash mark over. And I'm going to go up a half. Nice and easy to go up a half, right? That's just 0.5. So we plot that point. And then 90. Notice if I go over 90, that one's easy to find. I'm going to go up 0. So that's going to be right on my axis. So I can go ahead and plot that point there. Now make sure that you have plotted each of these points accurately. And then once you have plotted those, you've seen the general pattern here. You've seen how it works. So go ahead and now plot all of the rest of the points from our table. All right, so as you continue through, the next point that we had plotted, oops, don't want that, I want this, is going to be 120, which notice gives me negative 1/2. Since it's negative, sometimes we get so focused on the numbers that we forget that the negative is going to tell me to go down. So 120, that's over 30 from 90. And so I'm going to have to go down 0.5. So that should be your next point there for the 120 degrees. All right, and then when you filled in all of the rest of the points from our table, this is what you should be seeing on your paper. So of course, make sure all those points are plotted correctly. And now, having seen where those points are, we can now look at actually drawing a curve through them. So you'll notice some characteristics about what those points are showing us. Notice they're getting fairly compact as we get towards the top and the bottom. What that's telling us is that our graph is basically kind of leveling out at the top and at the bottom as it changes directions. This graph is steepest as we pass through the middle. And so that's going to be the steepest point. So as you draw this, you'll find yourself being flat at the bottom or the top and then getting steeper and steeper until you hit the middle. And then it starts flattening out again. And so now go ahead and draw the curve through these points and get a feel for what this graph feels like. And notice, you're only just doing up through 360 at the moment. So you're going to be looking at something like this. But notice what this graph feels like, so you'll be able to replicate that in future graphs that we make. But of course, I gave you this big old graphing grid, and we've only filled in half of it. Is this the entire graph of cosine? No, it's not. We can go further. So for instance, let's look here. I can actually plot a point right here at 390 degrees. And I can actually know fairly easily where it should be. Partly because, remember how we started class. Remember the idea of coterminal angles. This is why we started with that, just to kind of reinforce an idea here. Because 390 degrees is coterminal with what point that we already plotted? 30. Because 390 minus 360 is 30. So 390 degrees must give me the exact same cosine value as 30 degrees did. So I look over here and I see, okay, over at 30, I was up there. So I'm going to go over here to 390, and I'm going to put a point in the same place. And because of that, and because of that idea of coterminal angles, you can see that what this is going to end up doing is basically our wave is going to repeat itself exactly as you see it. And so knowing that, go ahead and repeat it. plot all the rest of the points to fill out the entire graphing grid now. All right, so when you plot all the rest of those points and draw the curve in, this is what you should be looking at. Notice the curve is just repeating itself. We're seeing the same thing. And I also want you to notice a few characteristics about this graph. Yes, it does go on forever in both directions, so it's just repeating itself. So if I know that like I'm at the top of my graph up here, I can use that to go either way. I know from the top I'm going to be heading down that way. I also know at the top I'm going to be heading down this way. So like I know that if I was asked what's happening to the left of that first point at 0, I know it's going to be starting to head down from there as I head to the left. Just because it's always following the same pattern. Now, a few other things to notice. So like if this is my middle line here, how high does the graph go above that middle line? 1. So this distance from here to here is 1. How far is it from the middle line to the bottom? It's down 1 as well. Yeah. And so notice it's symmetrical. There's this middle line where we have our zeros in this case, and we're going up 1 and down 1 from that middle line. And as you might imagine, we will be able to change some of those values along the way as well, right? Because you've seen this graph before, haven't you? You've seen this graph on WallMap. In fact, for the last couple of weeks, you've been seeing this graph pop up. It's just on WallMap up to this point, I haven't been calling it cosine of x because I didn't want you worrying about how do I graph cosine. I just wanted you looking at the shape and getting used to moving that shape around. On WallMap, this was the wave function. But now we can know wherever you are seeing that wave graph, it was cosine all along. You've been graphing cosine already. And because of that, you already know how to transform it. You can make all sorts of changes to this graph now because you've already done it on those problems. So we're going to do that with some of those extra graphing grids you have on that sheet. So next graph, we're going to be doing y equals negative cosine theta. Write that equation above your graphing grid. And then we're going to go ahead and make that graph. All right, so for making this graph, cosine normally at 0, it starts up at the top, right? It starts up at 1. Well, what's the negative going to do to that point?
It's a -1.
Yep, this negative here means that whatever my y value is, I multiply it by -1. So 1 times -1 is going to give me -1. The next point I'd normally plot over here at 90, I'm going to skip and just go over to 90 at the moment, is at 0. What does -0 equal? 0. Yeah, so this point is still going to be at 0. All right, next point. At 180, normally we put our point down at -1, right? What is a -1? Positive 1. 270, that's normally at 0. Of course, -0 is still 0. And 360 is normally up at 1. We can see that from our last graph, the first one we made. If I do -1, it gives me -1. And so I can plot those points, and I got a pretty good idea about what the graph is doing. But do I need to plot more points here? Because the first time we did it, we also plotted the 30s, 45s, and 60s in between, right? Do you need to here? Well, some of you yes, some of you no. I've made a lot of these graphs. I know what the graph should feel like. And I know if I need to redo it, I can redo it to make it look a little bit neater. But you're just making them for the first time here. What if you aren't so smooth at making these graphs yet? Well, we do know other points. And so you can plot other points in between. For instance, at 60 degrees, it's normally a half. So in this case, it's a -1/2. At 120, it's normally a -1/2. So here it's up at 1/2. Some of you might do yourself a big help, by drawing in the 1/2 points. Because then that will help you target those points and make your wave a little bit smoother. And that will help you to make your waves and get a good feel for what they should look like. Others of you don't need to draw those in. Do it if you need to make the wave look better. But if you don't need it, you don't have to make it. However, that being said, I want to caution you about something. Notice the shape of my graph here is a wave. It is not a lightning bolt. In other words, my graph here is kind of leveling out at the top and the bottom and all that. It is not straight between the top and the bottom. It kind of looks like it if you only plot the ones and zeros and negative ones. But you have to know that it's not. It's actually a wave through there. And so make sure that if you are drawing it with fewer points, that you're able to do so still smoothly and still make it into a wave. All right, next graph. Go ahead and write down this equation above your next graphing grid. And we've seen this problem crop up on the wall map practice as well, where we're graphing it multiplied by 2. But there's one problem that would often come up on the wall maps and can also come up on our paper if we aren't really careful. Because a lot of people will end up giving me this graph. But you notice there's an error in that graph. Or at least I hope you can notice the error in this graph. Because when I multiply by 2 here, it's a vertical stretch by a factor of 2. Now when I say vertical, notice I'm not saying upward. It's vertical because it's pulling it up away from the x-axis and it's pulling it down away from the x-axis. Which means that the point that's normally here at -1 is not going to be at -1. It's actually going to be down at -2. And so notice, for this graph, it's the same as my original, except instead of going up 1, down 1, I'm going up 2, down 2. Now there's a little trick you can do to help yourself avoid that mistake. A great way to start these, anytime you have a vertical stretch like this in there, is to draw in a dotted line for where the top of my graph should be, and then a dotted line for where the bottom of the graph should be. If you do that first, you know your points are going to have to go on one of those. So then if you go and you try to put a point here, that's a bit of a red flag because it's not on one of those lines, and so you can know that you made a mistake. It makes it a lot easier. Plus, as you're going to see as we go through this, there's a certain pattern with cosine. Cosine, notice, starts up at the top, right? It goes top, and then it goes to the middle, and then it goes to the bottom. And then it goes to the middle, and then it goes back to the top. If you draw in lines for where the top, the middle, and the bottom are, first thing, all you have to remember is top, middle, bottom. And you're going to be able to put those in just fine. Now, of course, one thing I haven't done on this one yet is draw in the curve. Yes, you would need to draw in your curve through those points that you plotted. So your graph should be looking like that. Now, as you check your graph, let's see how well your graphs are coming out, because this one's a nice one to be able to check on. This point should be up at 1/2. Did you actually hit that grid intersection with your curve as you are freehanding it? This one should be at this intersection, because these 1/2s, well, now they're 1s, because we multiplied it all by 2. So you should have been going right through those grid line intersections. If you didn't, if you missed them, then see how you need to tweak your graph so that you will be accurate with drawing those parts in. All right, next one. Go ahead and write down this equation. All right, so we got a +1 hanging on the end here. That +1 that hangs on the end of any of our equations that we have seen so far this year has always shifted the graph up 1. In the case of cosine, it is going to shift the graph up 1. Cosine follows all of the same rules that all of our other graphs have done. Now, the interesting thing, though, in this case is that in order to make that graph, it can sometimes be a little bit tricky to just freehand that and go straight to the points. Because we, again, can lose track of one of the points and where it should go. So you can actually, again, make your life a little bit easier by drawing in some dotted lines at the start. Like, if I'm going to move it up 1, what we're really saying is that I move my midline up to 1. So I would draw a dotted line up here at 1. So you know that's the middle of your graph. And so you know that your graph is going to be existing entirely above and below that. Now, how high above and below that should we be going? 1. Now, again, that can be a little bit tricky to remember. And so I would even go so far now as to draw in all 3 lines. We drew the midline in. I would also draw in the top and the bottom lines. Each of those is 1 away from the midline. So you notice here, as you take a look at that, this distance here and this distance here are both 1. Why is it 1? Because there's no number multiplied in front of cosine. If all of a sudden I gave you 3 cosine, then these numbers will become 3s. I'd have to go up and down 3 from the midline. Got the idea? But by drawing those lines in, I now can make my graph a lot easier. Because you notice, those lines that I drew in, I have a top line, I have a middle line, and I have a bottom line. The pattern for cosine that we have seen is that it starts at the top. So I put a point there on the top line. And then it goes to the middle. So I put my next point at 90 degrees in the middle. And then another 90 degrees brings me to the bottom. And then I go back to the middle. And then I go back to the top. And so really, you can boil down cosine to just this little pattern of going top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle, over and over again. It just does it for infinity until we fill up our entire graphing grid.
So that's it.
That is really all cosine is doing, is just iterating between those as a wave. And so if you know that pattern, you can draw cosine. And that's why I draw in those 3 dotted lines first, because those dotted lines are the top, the middle, and the bottom lines. And so once I draw in those points again, I draw in my curve. Get in the habit of drawing in that curve nice and smooth. Remember, I'm looking for waves, not lightning bolts. It needs to have that nice little curve at the top and the bottom. Next equation then. This is one that when you were first seeing them on wall map tended to cause the most questions. Hopefully we got a lot of those answered and taken care of, but if not, let's try to wrap them up today. You're writing down this equation above your next graphing grid there. All right, and so the minus 90 here. Notice the minus 90 in this case is inside with theta. Theta means the same thing of x's, of course, right? So anytime we have a number inside with x, added or subtracted directly to x, that means it moves it in the x direction. Minus moves it which way? Left or right?
Right.
Yep, to the right. And so what that means is that every single one of the points that I originally would have plotted, I'm going to now start them actually 90 degrees over to the right. So like this point that's normally up here at 1, at 0 is now going to be at 1 at 90. It's getting dragged over there. So I can go ahead and plot that point. The point that's normally at 90 is 0. Well, that's now going to be over to the right 90 degrees as well. So that's going to be over here. The next point I would normally plot is 180, negative 1. Drag it right 90. And so you notice, for every single point, I'm just saying, where would I normally put it? And then I'm just moving it right 90 and putting it at the new location. And so I now have all of those points plotted. A little detail, I didn't mention this earlier. Notice my midline is at 0 because there was nothing added or subtracted at the end. And I'm putting my top and bottom up and down 1 because, again, there's no number multiplied out front of the cosine. So that means we default to going up and down 1. All right, but based on the points that I've plotted, I can draw in this graph. But notice our graph is missing something here. I don't have anything graphed here. Does the graph continue to the left of 90? Absolutely. It continues forever. Left and right. It's an infinite wave. Well, there's basically a great way to fill it in is follow the pattern. So like I'm going to read my pattern from right to left. So starting at 360, I'm in the middle. Now, anytime we're at the middle, we can either be going to the top or the bottom. In this case, you can see it went to the bottom. Every time you're at the bottom, notice we go to the middle, because you can never jump straight from bottom to top, because of course, if you're going to go from bottom to top, you have to pass through the middle. And so I go middle, and then you can see it goes to the top. Well, I'm at the top here at 90. Can I go straight from top to bottom? No, because I have to pass through the middle in order to get there. So if I'm at the top here, my next one absolutely must be the middle. And so that's a way that we can know where that other point goes. We're just following the pattern to be able to fill that in. And then, of course, extend your curve to go through it. And this graph is now done. All right, now that we've gone through all of those, you've seen every individual transformation and how it shows up with the cosine wave. Well, you've done tons of graphing practice. We can put all of these together in lots of different ways. So what I'd like you to do now is take each of those transformations that we just did and put them all together in one graph. A hint at the start of this one, definitely you'll want to draw in those dotted lines for where the top, the middle, and the bottom go. Start by drawing in the middle, and then draw on the top and the bottom from there. All right, so the first thing you want to look for is you want to figure out where the midline is. Now the midline is determined by whatever is added or subtracted on the end. So in this case, our midline is going to be at 1. So I start by drawing in a dotted line here at 1. And so that's where the middle is going to be. I now need to draw in lines for the top and the bottom. Now the top and the bottom normally are up 1 and down 1 from that line. However, in this case, it has been changed. We do have a vertical stretch present here. The vertical stretch is whatever number is multiplied out front of it. Now, you might be tempted to call it a -2, but really the vertical stretch is just 2. And so what that's going to tell me is that the distance from the midline to the top is going to be 2. So I draw on the top line there. And the distance from the middle to the bottom is 2. And so then I can draw on the bottom line. Now that I know where the top, the middle, and the bottom are, I really have now taken care of a lot of the work for this one. At this point, I've dealt with the 2. So for the moment, I'm going to ignore the 2. So I'm just going to pretend that that's not there. And we can also say that we dealt with the +1. So I'm going to also ignore that and pretend it's not there for the moment. So notice, the only other things I need to consider is the negative and the -90. If you can figure out where your first point goes, you're going to have it from there. So focus on that first point from there. All right, so from there, cosine normally starts at the top. You got to know that one fairly quickly. The sooner you remember that cosine starts at the top, the easier these things are going to get overall. So normally, my first point goes up here, but of course we are changing it. We're changing it with 2 things. One, we got this negative out front. Remember, the negative flips it upside down. So bottom becomes top and top becomes bottom. So my first point is actually going to be on my bottom line. But I also have this -90 here. And remember, the -90 moved it to the right 90. So I'm going to take this point here and I'm going to put it over right 90. So this then is my first point. I now have used all those transformations. I can plot that point and the rest is going to be cake. because that point's at the bottom. What always follows the bottom? Middle. So at 180, I'm going to put a point in the middle. All right, I just went bottom and then middle. What must come next? Top. And so I put my next point at the top. What always follows top? Middle. And so we know all of those points as we head to the right. And just like we did with that earlier one, I follow the pattern going from right to left to know what's it going to be doing for that last point at 0. And you notice if that's at the bottom, the last one then must be in the middle. And so that is then your graph.